Okay, I want you to try something for me. Picture the universe. Not the stars and galaxies, but the actual fabric of it. We've all been trained to think of it as this bendy, warping, four-dimensional thing, right?
The rubber sheet analogy.
Exactly. Where time slows down if you move fast enough, almost like magic.
It's the standard model. It's what we've accepted for over 100 years.
Right. But what if that's all, I don't want to say wrong, but what if it's a massive technical misunderstanding?
Okay.
What if time dilation isn't some mystical property, but just lag? Like literal video game lag because the server is busy.
It's a very provocative thought. And that is exactly where we are going today.
Ah.
We are doing a deep dive into a really unusual set of documents. It's a series of analytical prompts, reports, generated by an AI persona.
An AI.
Yeah, it calls itself the Space-Time Structure Analyst, and the documents are dated January 18th, 2026.
Space-time structure analyst. I have to say, for something that claims to be dismantling Einstein, that is a wildly bureaucratic title.
It is, isn't it?
It sounds like a mid-level manager at a logistics company, not someone rewriting the laws of physics.
It's very understated. Just here to analyze the structure, ma'am.
Yeah.
But the content is, well, it's explosive.
So what are we looking at?
This analyst produced a unified physical model definition and some really detailed drafts on, of all things, the behavior of light in elevators.
Elevators.
And the mission for this deep dive is really to unpack its central argument that we need a total paradigm shift. We need to stop looking at Einstein's mathematical abstractions
And start looking at what?
and start looking at what the analyst calls electromagnetic field physical reality.
Okay, so we're trading abstract math for physical mechanics. So what's the roadmap for today?
We're going to start with this game server analogy for the universe, which I think is a great way in.
Okay, I like that.
And then we'll get into why light clocks on trains are actually using something called deflection shooting.
Which sounds like something out of a World War II dogfight.
It's a surprisingly apt comparison, you'll see.
And then there's a logic bomb.
A logic bomb, yes, involving the law of excluded middle. And finally, we tackle the big one, atomic clocks and GPS.
Right. Because if time doesn't warp, then those things shouldn't work. But this analyst says they do, just not for the reasons we think.
It's a heavy one, but I think it changes how you see literally everything around you.
So let's jump in. The source material starts with this idea of a three-tier reality. Hierarchy A, B, and C. It reads a bit like a software manual for the Matrix.
It does, but it's actually a brilliant way to strip away all the confusion. So hierarchy A is the absolute reference.
The bedrock.
The bedrock. The analyst calls it the electromagnetic field space. In our analogy, this is the game server.
Okay, the hardware the universe runs on.
Exactly. In this layer, the rules are absolute. And the most critical rule is that light travels at a specific speed, $7 through the field. It doesn't care about you or your spaceship.
The speed is fixed relative to the server. Got it. What about hierarchy B?
Hierarchy B is the subspace, or, moving objects. This is us, the Earth, a train, an atom. The analyst describes them as clusters of atoms swimming through that field.
We're the players, moving through the server's world.
We are. And that brings us to hierarchy C.
Which would be the screen.
The screen. Hierarchy C is interaction, or the UI, the user interface. It's what the player sees.
Okay, so this is where the conflict starts, isn't it? Because in a video game, what I see on my screen, my UI, isn't always what the server's actually doing. There's lag.
That's the absolute crux of the argument. The analyst says that for a century, physicists have confused the UI with the code.
What we see with what's real.
Right. Just because an observer sees something delayed or distorted, it doesn't mean the server itself, time and space, has actually warped.
But this is the part I struggle with. Einstein's whole thing was that there is no server, there is no absolute reference, everything is relative. If I see time slow down, it actually slows down.
And the analyst says that's a geometric perversion.
Why?
They argue that Einstein took an optical illusion, one caused by signal delay, and turned it into a law of nature. He built a physics based on the laggy screen, not the processor.
That is a bold accusation. But let's look at the evidence they give. They go back to the classic example, the one in every textbook.
The light clock on the train.
Right, the thought experiment. You've got a train moving really fast, say 10% of the speed of light. Inside, there's a light on the floor and a mirror on the ceiling.
And it shoots a pulse of light straight up, hits the mirror, comes back down. Tick, tock. It's a clock.
Okay, and the standard Einstein explanation is, if I'm on the train, I see the light go straight up and down.
Vertical path.
But if you're standing on the tracks watching it go by, you see the light move in a diagonal line because the train is moving forward.
Correct. And Einstein famously says both views are equally valid.
But the space-time structure analyst calls this Einstein's laziness. Why?
Because they bring in this idea of deflection shooting.
The dog-fighting thing.
Exactly. Imagine you're a duck hunter. If you aim directly at a moving duck, what happens?
You miss. It flies right past. You have to lead the target.
You have to shoot ahead of it. Now, apply that to the light clock. The mirror on the ceiling is a moving target.
Because the train is moving.
So if the photon just went straight up, relative to the universe, relative to the server, it would miss the mirror completely.
Ah, I see that. The mirror would have moved forward by the time the light got there.
So for the clock to actually work, for the light to hit the mirror, the light must be traveling diagonally relative to the tracks. It has to chase the ceiling.
It has to take the hypotenuse of the triangle.
And this is where the math gets physical, not magical. We know light speed is constant in the medium. It can only go so fast.
Right.
If it has to travel a diagonal path, that path is longer than the straight vertical path.
The hypotenuse is always longer than the side, yeah.
So, basic physics. Distance equals speed times time. If the speed is fixed and the distance gets longer, what has to happen to the time?
The time has to get bigger, it takes longer. And
Precisely. The analyst calculates that instead of, say, 10 seconds, it physically takes 10.05 seconds to make the trip. The tick of the clock is delayed.
so the clock ticks slower. But Einstein says time dilation means time itself slows down. This is just mechanical.
Think of it like this. If you and I are playing catch and I start running away from you, the ball takes longer to reach me. Sure. You wouldn't say, oh, wow, time slowed down for you. You'd just say the ball had to fly farther, so it took longer to arrive.
That's distressingly simple. The analyst is saying we looked at a ball taking longer to reach a runner and decided to invent a fourth dimension to explain it.
That's the argument. They call it process lag. The light had to swim farther through the medium to catch the mirror. The process took longer. It's an engineering problem, not a metaphysical one.
Okay, but hold on. I have to play skeptic here. Einstein was a smart guy. He knew about hypotenuses. Why did he insist that for the passenger, the light goes straight up?
This brings us to the logic bomb section of the report. The analyst uses something called the law of excluded middle.
Which sounds like a terrifying legal term.
It's just basic logic. It says a proposition is either true or false. There's no middle ground.
Okay.
The analyst applies this to the photon itself. We're talking about one particle of light. A single bullet. Can a single bullet have two different physical trajectories through space at the same time?
Well, relativity says yes, depending on your frame of reference.
And the analyst says, objection. Imagine looking at this train from the North Star, a God view, looking down on everything, the absolute frame,
The server view.
the server view.
Yeah.
From that view, the light must be moving diagonally to hit the moving mirror. It has to.
Right. If it went vertical relative to the tracks, it misses. Case closed.
So if it is physically moving diagonally relative to the field, it cannot also be moving vertically relative to the field. It's one or the other.
You can't have both.
You can't. So the vertical path the passenger sees,
Mm-hmm.
that's the illusion.
That's the UI. It's a trick of perception because the passenger is moving with the light source. The analyst argues Einstein built his theory on that optical illusion and ignored the server reality.
So the passenger thinks the light went straight up, but the server logs show it went diagonal. And reality doesn't care what the passenger thinks.
Exactly. The analyst calls the vertical path the non-existent solution. It's a ghost. It never physically happened in the electromagnetic field. It only happened in the passenger's brain.
This makes sense for mirrors and beams of light. I can visualize it. But the skeptics, and I can hear them screaming in my head right now,
They're going to say, what about atomic clocks?
it's the inevitable question.
Right, because atomic clocks are the gold standard. They use cesium atoms. They are not bouncing light off ceiling mirrors.
No, they are not.
Yet we know for a fact, it's been proven, that if you put an atomic clock on a fast spaceship, it slows down. How does deflection shooting explain a vibrating atom?
I love this part. Because the analyst just doubles down. They ask, what is an atomic clock, really? It's not magic. It's an oscillator.
A counter.
It counts the frequency of electromagnetic waves, microwaves, to be specific.
Okay, so we're back to electromagnetic waves again.
We're always back to electromagnetic waves. Think of the atom as a micro-light clock. There's a source and a detector. If the clock is sitting still on the server, the waves hit the detector. Tick, tick, tick.
Simple enough.
Now, put that clock in motion, moving fast through the electromagnetic field. The detector is physically moving away from the source of the signal, even on a microscopic scale. The signal has to chase the detector.
It's the train ceiling all over again.
It is. But the analyst uses an audio analogy here that I think lands a bit better. Think of the Doppler effect.
Like an ambulance siren dropping in pitch as it passes you. Ni-now, ni-narrow.
Exactly that sound.
Yeah.
Why does the pitch drop? Because the ambulance is running away from the sound waves it just created. They get stretched out. Fewer waves hit your ear per second.
Okay, I get that.
Now apply that to the atomic clock. If the clock is moving through the medium, the internal detector is running away from the signal pulses.
So it catches fewer ticks per second.
Because the signal has to chase it down, so the counter counts a lower number.
Yes, the clock shows less time has passed.
Not because the flow of time changed, but because the mechanical process of counting was slowed down by motion through the medium.
It's like trying to count raindrops while running away from the storm. You're just going to catch fewer drops.
Mechanical slowing. That's the term the source uses. The clock is a machine, and it becomes less efficient when it works against the lag of the medium.
Okay, so if this is true, that it's all about moving through some absolute ether or field, then we should be able to prove it with direction.
Hope so.
Well, Einstein says only relative speed matters. This analyst is saying direction relative to the server matters.
And that brings us to the Hafeel-Keating experiment.
The famous one with the clocks on the airplanes flying around the world.
Usually cited as the ultimate proof for Einstein. But the analyst looks at the data and says, wait a minute, this actually proves my point.
Okay, let's break it down. They flew clocks east and west.
Right. Now think about the Earth. It's rotating to the east. The surface is moving at about 1,000 miles per hour relative to the center.
So we are all currently zooming east.
Yes. Now, take a plane and fly it east. You are adding the plane's speed to the Earth's rotation. You are moving super fast relative to the non-rotating electromagnetic field.
You're moving really fast through the ether.
You're maximizing your speed against the medium, so you get maximum wind resistance for the light signals, maximum lag.
The signal has to chase the detector the hardest, so the eastbound clock should slow down the most.
And it did. The eastbound clock lost the most time.
Now for the brain burner. The westbound plane, flying against the Earth's rotation.
This is where Einstein and the analyst really diverge. For Einstein, it's complex math with gravity and relative frames. The analyst just says, look at the speed relative to the server. If the Earth spins east at 1,000 miles per hour and you fly west at 500 miles per hour, what are you doing?
Subtracting speed, you're actually moving slower relative to the center of the Earth than the guy standing on the ground.
Exactly. This is the paradox. By flying west, you are closer to being still relative to the electromagnetic field than you were on the ground.
That is wildly counterintuitive. Getting in a 500-mile-per-hour jet makes you slower in the absolute sense.
Relative to the field, yes. And because you are moving slower through the medium, there is less lag. The clock becomes more efficient.
So it ticks faster than the ground clock?
Or rather, it slows down less. And that is exactly what the experiment showed. The westbound clocks gain time relative to the ground clocks.
And the source says this implies the existence of an absolute ether.
Yes. It references the Lorentz ether theory. The fact that east versus west matters, that there's an asymmetry, suggests there's a background we're moving against. If space were truly empty and relative, why would direction matter?
Direction matters because the server is there. The medium is real.
You know, we're taught in school that the ether was disproven. Michelson-Morley, 1887, case closed.
Right.
The analyst argues we threw the baby out with the bathwater. We couldn't detect it mechanically, so we decided it didn't exist. Then we had to invent space-time curvature to explain everything. We basically just renamed the ether space-time and gave it magical geometry instead of physical properties.
It's a rebranding exercise. It's not a bug. It's a feature. Time travel.
Pretty much.
There is one last thing from the source I want to touch on because it's haunting. It's this visual that really drives home the whole UI versus code idea.
The ghost shoe.
The ghost shoe, yes.
This is where the physics gets personal.
The source asks us to imagine a passenger on that high-speed train, just looking down at their own shoes.
Seems like the most immediate thing in the world. You look down, you see your foot. It happens now.
But it doesn't.
No. Light takes time to travel from your shoe to your eye. It's a tiny, tiny fraction of a nanosecond, but it's not zero.
And since the train is moving...
In that tiny split second, the light is traveling to your eye, your physical foot, the actual atoms of your shoe, has moved forward.
So the light left the position where my foot was, but my foot isn't there anymore.
Correct. By the time that image hits your retina, your physical body is already ahead of the image you are seeing. You're looking at a ghost image from the past.
The real body is always slightly ahead of the image body.
That is actually kind of terrifying. It means I'm never actually seeing myself where I am. I'm seeing a trail.
You are seeing a history log, and the analyst's point is, if you trust your eyes, you think your foot is at position A. But the server knows your foot is at position B.
Einstein built a theory on position A, what you see. The analyst wants a theory based on position B, where you actually are.
It really dismantles the idea of now. We think of now as this thing we're all experiencing together, but this suggests now is the server time, and we're all just experiencing different amounts of lag.
We are living in the buffer. The source asks a really biting question. Is modern physics based on a geometric perversion? Did we confuse a longer travel time for a slower flow of time?
It changes the universe from this magical place where time bends into a very rigid, mechanical place where our sensors are just slow.
It removes the mystery, but adds a different kind of complexity. It suggests the now is universal. The clock on the wall ticks the same everywhere. We just get the memo about the tick at different times, depending on how fast we're running from the messenger.
So what's the big takeaway here for the person listening who just had their entire worldview scrambled?
I think it's a call to critical thinking. It asks us to look at established theories, even the giants like relativity, and ask, is there a simpler physical explanation?
Right.
Sometimes mathematics can hide the physical reality. We accepted that time bends because the math worked out, but maybe the math worked because it was just modeling the lag, not the time itself.
It's like realizing the map isn't the territory, the UI isn't the code.
That's the perfect summary of it.
I want to leave our listener with this one final thought. If this analyst is right, if time doesn't warp and it's all just signal delay, then when you look at the stars or your friend across the table, or even your own hand, you are never, ever seeing reality. You're watching a delayed broadcast, a rerun.
We are all just echoes in the electromagnetic field.
On that uplifting note, thanks for joining us on this deep dive into the Space-Time Structure Analyst's report.
Always a pleasure to break reality with you.
Keep asking questions, check your lag, and we'll see you in the next deep dive.